So hello everyone, welcome to our channel. I knew the videos are not coming from many time. So yeah, I have come up with a good question today. We will try. The question is not too tough, but it will definitely teach you a good concept if you are not aware of that. So yeah, let's discuss the question now. So the question is corporate flight booking. The question says there are n flights that are labeled from 1 to n. Okay. We are also given an array of bookings which do have bookings of i's first, last, and seats that represent a booking for flights first of I through last of I inclusive with seats of I reserved for each flight in the range. Okay, so they are saying for each booking we are getting seats of I being reserved from for each flight from first of I to last of I. So let's say the query can be 1 to 10 with 5 seats reserving. That means for each flight 1, 2, 3, 4 till 10, 5 seats are reserved by this booking, right? So this is what this statement means. Now we need to return an answer of length n where answer of I represent the total number of seats reserved for flight of I. Okay, so we need after processing all the queries, basically these are queries. So after processing all the queries, we need to return the total number of seats reserved for each flight, right? So yeah, let's go through this example test cases and let's figure it out how we can solve it. So yeah, so the test case is like we do an bookings array. So basically the number of flights are 5. So the number of flights are 5. Let's say they goes from 1, my bad, 1, 2, 3, 4, 5. So we do have 5 flights. The first query says from first to second flight 10 seats are reserved from first booking. So first and second only, right? The range is simple, 1 to 2, both inclusive. Rest in this query, rest of the flight doesn't get any booking, so we will mark them with 0. Now the next booking said second to third. That means first flight doesn't get any bookings here. Second flight get 20 booking. Similarly, third get 20 booking. Again 0 for fourth and fifth. 0 for fourth and fifth. Yeah. Now the third booking says from second to fifth flight we get 25 seats reserved for each flight. So the first one again get nothing. Second get 25 reservations. Third again get 25. Fourth get 25 and similarly fifth get 25. So finally we can see the total number of reservation each of our flight got. We can do simply the sum total here. Right. So here for the first we can see the sum will be 10. For second 10 plus 20 plus 25 will be 55. Then 20 plus 25 will be 45. For the fourth we get 25. For the fifth it is 25. So yeah. So finally we get the answer 10, 55, 45, 25, 25. Let's try to match it here. 10, 45. Yeah. So this is what we got. So the brute force solution you can see clearly from here itself, from our test case dry run. That is simply we will try to go into each bookings. We will loop from start to end and try to add the number of seats reserved to the counter. And finally we can return the entire array. Right. So let me quickly write the brute force approach. So the brute force, that is pretty straightforward. So let's say vector of n flights of n plus 1. Why n plus 1? Because we can clearly see here the flights are from 1 to n, right? That's why. So n plus 1. Now we will loop into all the bookings. Let's call it b bookings. So we have here in first, that is simply b of 0. We have in last flight b of 1, and the number of seats that are being reserved is equal to b of 2. Correct. Now what we'll do, we will simply try to loop over start till last, from first to last. Sorry, start is not there. From first to last I plus plus. We will simply try to increase this many reservations, that is seats. And finally we can we cannot return the flights here, reason being this is one based indexing and the answer request only the size of array n. We need to return an answer of length n, so we need to create, so simply we can create one more array here. Let's call it answer, and we can move from for int I first flight till the n flight. Simply answer dot pushback flight of I, that is the number of reservation the ith flight got. We can finally return the answer. Let's try to test this. Yep, this works as expected. Let me now submit it. What it breaks here, sorry, that is flights. It worked. Finally submitting it. Yeah, so it is being accepted. The time complexity is too high. The constraint here given were of n is 10 to the power 4. So ideally it should not have been accepted, but the LeetCode have weaker constraints here. So we will try to optimize it further. With a better solution, we will try to learn a new approach here. So yeah, I hope you are aware of prefix sum. So let me try to enumerate it again with the same example test case. So I have drawn here an array which will be basically representing each flight. So let's say this is our 0th flight, first flight, second flight, third, fourth, fifth, and we will try to take one more with the sixth. I will tell you the reason a bit later, but for now you can think of it like this. Yeah. So yeah, now what we will do is we will try to process the queries again. So the first booking query says first till second book 10, reserve 10 seats. So what we will do is we will simply add plus 10 at the first flight, and since we need to add it till the last one, but at the last plus one we will try to negate the effect there. So what we will do, last is second, so second plus one, that is third. At third we will do minus 10. Okay, so this will entirely negate the effect for the previous range that we got, right? Okay, now the second query that we got is from why this will work is, let's try to take the prefix sum for the first query itself. So when you take the prefix sum, it will be plus 10, then here it will be again 10, here again it will be like 10, sorry, my bad. So here it will be again 10 plus 10. Now when we will try to carry it forward on third, plus 10 will negate the effect and make it 0, right? So no further, so it won't count for any further processing. It will count for only this range. It won't get further, right? No, here the effect is negated, so it won't be carry forward onto the next flights. So I hope you got the concept. So let's try to move with the next booking. So the next booking says that from second flight to third flight 20 seats are reserved. That means at second we will increase, I don't know why it is not working. Yeah, so let me do it here and then we'll take it there. So at the second we will increase it by plus 20, and at the fourth position we will decrease it by minus 20. Okay, the same as end plus 1, end is third, so third plus 1 we will try to negate the effect. Now the last query says from second to fifth 25 seats are reserved. So at second position again we will increase 25 seats because we got this many registrations more, and on the fifth plus 1, that is 6, in order to negate the effect we will try to add minus 25. Right, now we will simply take the prefix sum for the entire array. So the prefix sum will be 0 here, here it will be 10, here it will be 10 plus 20 plus 25, that will be 55. 55 minus 10 will be simply 45. 45 minus 20 will be 25, and here it will be 25. Taking it more, it will be 0. So you can see the answer is same. For the first flight we got 10, second 55 reservation, for third 45, for fourth 25, for fifth 25. So the answer is same. So I hope you got the concept of negating the effect of the previous queries, right? So yeah, this is the earlier approach. Now the new approach is pretty straightforward. Instead of looping over each one, in the worst case we might loop for all the n arrays. Like the query can be 1 to n. In all the flight got the reservation of x number of seats. So in the worst case it will be n square. So but now with our prefix sum and negation effect concept, we can simply do it in of 1 in the inside one, because we will simply try to increase it. So first we will simply increase by seats and flight of last plus 1, we are just simply negating it the effect with seats. It might go out of bounds, so I will try to take it n plus 2. Now finally we do have our entire, we will try to make the answer again the similar way and it will return it. So let's see. It is giving me the wrong answer. Let me check it. First is getting increased seats by n plus 1. For I, initially it is 0. Last plus 1, we have negated all the seats. Now we are moving. Oh, we haven't taken the prefix sum. Sorry, my bad. So we will try to take the prefix sum I equal to 1 to I is less than equal to n. I plus plus flight of I plus equal to flight of I. I hope you are aware about prefix sum. So yeah, this will take the prefix sum, and finally we are building our answers similar way we did in the brute force. And yeah, it worked. Now let me try to submit it. Earlier the time it took to submit run is like more than 1500 ms. Now it run in 28 seconds only. So you can see there is drastic increase in time complexity, and the approach now works in linear time complexity O of n. Earlier it was O of n square because the loop inside loop, right? So yeah, I hope you enjoyed this concept and you can apply it at many places. It comes handy. So yeah, if you enjoyed the video, please do like and subscribe to our channel. Thank you.